Alright, so this is the beginning of chapter 13. It's on using something called trigonometric identities. That's what a lot of this chapter is about. And it is definitely a difficult topic the first time you're doing it, but really more than any other topic, maybe this is just a question of doing it very frequently. If you practice a lot at this, you start to see the patterns and it gets easier. So it's all about doing a bunch of practice. So two things that we want to do in this section. Number one is talk about, first of all, what is an identity? I didn't write that there, but that's the first thing. What does it mean to say that something is identity? And then we'll talk about trig identities in particular, how to use them to find trig values like the sine of something or the cosine of something, and then using them to simplify different expressions. So first question, what is an identity? And the best way to understand it is to compare it with an equation. So on the left side, we have an equation. If we were to solve that for x, we would subtract 3 from both sides, and we would get x equals 2. Okay? It doesn't have to be only one answer, so we could have, for example, x squared is equal to 25, and we would solve that by square rooting both sides. We would get x equals plus or minus 5. Here's the main thing. This side, these two things that we just did are equations, because they're only true for some values of x. Right? So the top one is only true for x equals 2. The bottom one is only true for x equals 5 and negative 5. Only some x values make that true. This right here is what's called an identity. Identity is true for every single x value. And let's prove that. Basically, identity means that the left side and the right side are identical, or they're the same as each other. So if I took the 2 and distributed it, I get 2x plus 6 equals 2x plus 6. Let's subtract 6 from both sides. We get 2x equals 2x. Divide by 2, and we get something that's identical. X is equal to x. Now think about it. Whatever x value you plugged in there, no matter what it was, it would always be true. So let's set x equals 3. We would get 3 equals 3. Let's let x equal a trillion. We would get a trillion equals to a trillion. So no matter what x value I plug in, I'm always going to get something that's true. The left side and the right side are always going to be identical. That's not the case for an equation. If you look at the left side, that's only true. This one over here, this is only true. The left side and the right side are only true when x is plugged in with 2 right there. That's the only way to make those identical. This side right here, this is identical no matter what. That's a very simple identity, but that's the main idea. The difference between an identity and an equation is only true for some x's. Identity is true for every single x. Okay, so now in a trigonometric identity, there's a whole bunch of them. But basically the idea for showing that a trigonometric identity is true is that if we can show that both sides are identical, we've proven. If we can find a single counterexample, then that means it's not true. A counterexample, this is what this says right here. It only takes one counterexample to show that something is not an identity. So let's use the one we just did. I'm going to prove that this is not an identity. Here's a counterexample. If I plug in 4 right here, those are not identical. So that is not an identity. It is an equation, but counterexample just means find a single thing that shows that it's false. Okay, here's a big list of trig identities, and you don't have to worry so much about what all these mean. Some of these are hopefully familiar from chapter 12 when we talked about sine, cosine, and tangent. So SOHCAHTOA, for example. Sine means opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, here are the main ones to know, and you really don't have to memorize these. You'll have this, if you're tested on this, usually they give you a sheet. But this right here, it's important to know that tangent is equal to sine over cosine. We said sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Dividing by this fraction right here is the same as multiplying by its reciprocal. And if you did that, the h's would cancel and you would get opposite over adjacent. What's another name for opposite over adjacent? That's the same thing as tangent, right? That's what TOA means. Tangent is opposite over adjacent. Cotangent is the reciprocal of tangent. So you just take sine over cosine, you flip it over. Okay, these are also reciprocal, so there's 3 other ones that we touched on. Sine is the reciprocal of cosecant. Cosine is the flip or the reciprocal of secant. We just said tangent is the reciprocal of cotangent. And those work the other way. So cosec is 1 over sine, sec is 1 over cosine, cotan is 1 over tan. These 3 right here are probably the most important. I'll prove one of these to you in just a sec. And then, like I said, those other ones, we'll use them as they come up. Alright, so here's the proof, and this is the most important Pythagorean identity. Actually, last year I remember offering to somebody that they don't have to take any trigonometry tests for the rest of the year if they can prove that this is wrong. And that's because all of trigonometric identities depend on this one right here. So there's two different proofs for that. I'll just show you the right triangle one. That's a little bit easier. So here's a right triangle. And actually, instead of using x, normally what we use is theta. Theta is to trig what x is to algebra, so we'll just call those theta. Let's say I have this right triangle. There's my theta. Okay, this side is opposite to theta right here. This side is adjacent to theta, and this side is hypotenuse. So I want to prove that this is identity. I want to prove that if I take the sine of an angle and square it, and I add the cosine of an angle and square that, I will always get 1 no matter what, with no exceptions. Here's the proof. Okay, the sine of theta is going to be opposite over hypotenuse. That's what this acronym here means, SOHCAHTOA. Sine means that the sine of an angle is its opposite side over its hypotenuse. So the sine of theta is opposite over hypotenuse. That's what O over H stands for. And we're squaring that according to this identity. So we're going to square that. The cosine of theta squared, that's going to be the adjacent over hypotenuse. That's what cosine means. Cosine is adjacent over hypotenuse, and we're squaring that. And we want to know, does this in fact always equal 1 for any angle? So that's the key. An identity should be true for any angle, not just for special angles, or for all of them. Okay, well, let's do this. Opposite over hypotenuse squared would be opposite squared over hypotenuse squared. Adjacent over hypotenuse squared would be adjacent squared over hypotenuse squared. Again, we're not sure if this equals 1 yet. That's what we're trying to prove. Okay, well, these have a common denominator, so that means I can combine them, and I have opposite squared plus adjacent squared. It's supposed to be an A right there. So opposite squared plus adjacent squared. Again, still wondering, does this equal 1? Well, let's think about it. Opposite squared plus adjacent squared. Let's go back up to this picture. This is a right triangle, and you might remember with right triangles that there's a famous theorem named after Pythagoras, and it says a squared plus b squared equals c squared. What is a squared right here? A squared is the opposite squared. And what is b squared? B squared is adjacent squared. I don't want to confuse you. This a right here means adjacent. So let me add adj for adjacent. What does that equal? That equals c squared, which is the hypotenuse squared. So let's keep that in mind. Opposite squared plus adjacent squared equals hypotenuse squared. Why is that true? Because that's just a different way of stating the Pythagorean theorem. So opposite squared plus adjacent squared, we just said, right here, we just said that's supposed to equal the hypotenuse squared. So this whole thing right here equals h, or hypotenuse squared, and we had over hypotenuse squared. What does this equal right here? This equals 1. So that's a proof that for every single angle, it's always true that the sine squared of an angle plus the cosine squared of an angle, that's always going to equal 1. Okay, you don't have to remember that proof. It's just interesting to know that's an example of how you would prove an identity. Okay, so here we're actually going to get into finding values right now. So there's a couple of things to keep in mind. The first thing is to tell what quadrant we're in, and there's an acronym from earlier in chapter 12 which says all students take calculus. And what does that mean? That means in quadrant 1 every function is positive. In quadrant 2 only sine is positive. And by the way, the thing that goes with sine, which is cosecant, that would also be positive. In quadrant 3, tangent or cotangent is positive. And in quadrant 4, cosine or its reciprocal secant is positive. So we want to find the exact value of cosine if sine is positive 1/4. Well, there's two places that sine would be positive, and that's quadrant 1 and 2. How do we decide? Well, they told us that the angle we're dealing with is between 90 and 180. So here's 0, here's 90. Here's 180. So if we're between 90 and 180, that means we're in this quadrant right here. We're in quadrant 2. And what is cosine in quadrant 2? Cosine is negative here because the only things that are positive in this quadrant are sine. Let me add that sine and cosecant. So we know that our final answer, if we do this correctly, should be negative. How do we use trig identities to do this? We had a method for doing this in chapter 12 by drawing a right triangle. Let's use trig identities. So here's the main one. This is the most important one, and it comes from this sheet right here, the Pythagorean identities. We just proved that using the Pythagorean theorem. So if they're asking us about cosine, we're going to use the identity that has cosine in it. Okay, so here's Here's how we do that. So let me just write that identity right here. Sine squared of an angle plus cosine squared of an angle is equal to 1. Well, they're giving us sine. They're telling us sine is 1/4. So let's just plug that in right here. And this is basically how you do this. You pick which identity you're going to use. How did I know to use this one? Because they're asking us about cosine. And they gave us sine, so I have to use the one that has sine and cosine in it. Usually you use the one for what they give you. They're giving me sine, so this one has sine in it. So I'm going to plug in the 1/4, and then we'll just solve this. And this is now a regular algebra equation. So 1/4 squared is 1/16. Okay, and then this is going to be equal to 1. How do we solve this? We want to isolate the cosine squared, so we'll subtract 1/16. 1 is the same as 16 over 16. So 16 over 16 minus 1 over 16 would be 15 over 16. And that's equal to cos squared. How do I solve for cosine if it's cosine squared? Well, I need to cancel out the squared by square rooting. And I'll square root this side. Square rooting a fraction is like square rooting the top and the bottom. And also whenever I take the square root, I do plus or minus. So those cancel. So we get cosine theta equals plus or minus the square root of 15 over, what's the square root of 16? That's 4. So we get plus or minus, let me write it up here, it's a little bit bigger. Plus or minus the square root of 15 over 4, but it can't be both. We have to decide which one it is. How do we decide? We said at the beginning we're in the second quadrant right here. And in the second quadrant, cosine is negative. So that means the final answer will be the negative right here. Negative root 15 over 4. That is our answer. And how do we do it? We used this trig identity. We used sine squared plus cosine squared is equal to 1. Okay, this one says find the exact value of cosecant if cotangent equals this. So let's just figure out what quadrant we're in again. All students take calculus. Some of these problems are not going to tell you this part, by the way. Here they told us. But cotan is negative. So here everything is positive. Here only sine is positive. Here tangent is positive. Here only cosine is positive. So cotan and tan have the same positive or negative value. So tan is negative in these two quadrants. That means cotan is also negative here. So how do we decide if we're in the second or the fourth? Well, they're telling us we're between 270, which is this angle. Here's a 270 degree angle. This is 180 right here. This is 90. And 0 and 360 are the same. 360 is where you make a full rotation. So we're between 270 and 360. That means we must be in the fourth quadrant. And in the fourth quadrant, cosecant, well, remember, cosecant goes together with sine. Sine is the same as 1 over cosecant. But they're not negative reciprocals, they're just regular reciprocals. So whatever cosecant is, positive or negative, that's what sine is going to be. So in the fourth quadrant, sine is negative. That means cosecant will be also. So I'll just write a negative there to remind us. Okay, now where do we go from here? We're given cotan. They just say find cosecant. How do we use identities for that? And let's go back to our identity table right here. So they gave us cotan. Keep that in mind. These are the ones that we usually end up using, the Pythagorean identities. Which one has cotan? It's this one right here. And by the way, I just want to show you where these other two come from. So we proved the sine squared plus cosine squared one. Where do these other two come from? Let me show that to you right now. They're all based on this one. So let's suppose I took this and I divided everything by cosine squared. As long as I do it to one side, I can do it to the other. Cosine squared divided by cosine squared is 1. Sine over cosine is tangent. So sine squared over cosine squared is tangent squared. And 1 over cos, well, what's the reciprocal of cos? We said it's up here. The reciprocal of cos is this. It's secant. So 1 over cos squared would be sec squared. So notice this right here is that identity right there. How do you get this one right here? You do the same thing, except now instead of dividing by cos squared, we'll divide by sine squared. So let's take this, and we'll divide everything by sine squared. Okay. Sine squared over sine squared, that's 1. 1 over sine squared, 1 over sine is cosec. And cos over sine is cotan. So we want to use this identity. How do we decide? Because they started out in this problem by giving us cotangent. And so I'm going to use the cotangent identity. That's probably one of the hard parts for people, is how do you decide which one to use? We're going to use this one right here because that's the one that they gave us. Okay, so they're telling us cotan is negative 3/5, so let's plug that in for cotan, and we'll square it. And then it has to equal this, and we're being asked to find cosec squared, or sorry, we're being asked to find cosec, and this gives us cosec squared, so at the end we'll have to square root it. So negative 3/5 times negative 3/5 is 9 over 25. Okay, this right here as a fraction is 25 over 25. That's the same as 1. Okay, what does this equal right here? Well, they have a common denominator, so let me just move this over here. So 9 plus 25 is 34 over 25 equals cosec squared. Okay, now to solve that we need to square root it, and we'll square root this side also with a plus or minus. 34 cannot be simplified, so we'll leave it as plus or minus root 34. Square root of 25 though is 5. So that's what cosec is. How do we decide whether it's plus or minus? Well, we said at the beginning that we're in the fourth quadrant. That's what this is. And the fourth quadrant cosec is negative. So this is going to be negative root 34 over 5. And that's how we use trig identities to solve. These are pretty much the same. So I think maybe we'll do one more here. Let's do 1b. Because 1b is a slight variation. 1a we kind of already did. So we want to find secant given sine. So because they gave us sine, that means we're going to use the identity that has sine in it. Here's the problem. This one doesn't have secant in it, so how are we going to find it? Well, I'll show you at the end. Let's just start by finding cosine. And this tells us we're between 180 and 270, which means we are in this third quadrant, and according to all students take calculus, only tangent and cotangent are positive here, which means secant will be negative. So I like to put the negative there just to remind that our final answer should be negative. So sine is negative 2/7, so that's what we're going to square. And this is going to be equal to 1. Now we'll simplify. Negative 2/7 times negative 2/7 is 4 over 49 plus cos squared, and that's equal to 1. We'll subtract 4 over 49 from both sides. And 1 as a fraction would be 49 over 49. Oops. So this is, get rid of all this stuff down here. All students take calculus. That doesn't need to be there though. So 49 minus 49, or sorry, 49 over 49, that's what this is, minus 4 over 49, that would be 45 over 49, and that's equal to cos squared. And we want to solve this by square rooting both sides and putting a plus or minus in front. So that means cosine is going to be plus or minus root 45, and over the square root of 49 is 7. Okay, and then here's the thing about root 45, we're going to have to simplify that. But I'm not going to do that yet, and here's why. We're not originally asked to find cosine, we're asked to find secant. And we have to be aware of this identity right here. This is why these can be tricky, because there's a lot of identities to keep in mind. So here's the identity. What's the relation between cosine and secant? And that's the reason why they asked us secant. We have to be able to get from cosine to secant. Here's the relation right here. Cosine is 1 over secant. So for example, if cosine is 5 over 7, then that means secant would be 7 over 5. We just have to flip it over. That's the easiest way to get from one to the next. Okay, so let's go back here. So we know that cosine is this, and also we knew from the beginning that it's going to be negative because we're in the third quadrant, so we're only going to take the negative. So if cosine is that, then that means secant is the flip of that. It's negative. I'm going to put the 7 on top and the root 45 on the bottom. So that's secant. And that's not wrong, but it's not really simplified right now, so let's simplify that. So we'll rationalize the denominator. There's another way you could have done this too, but we'll keep it like this for now. So we get negative 7 radical 45 over 45. And now radical 45 has a perfect square in it. Radical 45 is 9 times 5. So the square root of 9 is 3, and we still have that radical 5. So this becomes negative 7 times 3 radical 5 over 45. And before we multiply 7 and 3, let's cancel these. So 3 goes into itself once, and it goes into that 15 times. That's the same as negative 7 root 5 over 15. That is what secant equals. How do we know it's negative? Because they told us at the beginning that we're in the third quadrant. And there it is right there. Alright, last thing we want to do in this section is learn how to simplify expressions. And there's a chart that I made to help people with this, how to prove trig identities, and there's 4 basic strategies. And we won't worry about strategy 1 or 2 yet. Okay, here's what the one thing I want to say. When in doubt, is a strategy 4. When in doubt, change everything into sines and cosines. That is your go-to strategy. So if you look back at this identity sheet that we've gone to a couple times, notice that every single trig function, there's 6 of them. There's sine, cosine, tan, cotan, sec, cosec. So tangent can be changed into sines and cosines right like that, and cotangent like that. And cosec can be changed into 1 over sine, and sec can be changed into 1 over cosine. So every trig function can be changed into sines and cosines, and the vast majority of these problems, that's exactly how we'll do it. Alright, so this one right here, change everything into sines and cosines. So sine theta. What is cosec? Cosec is 1 over sine. So I'm changing everything into sines and cosines. And cotan is the reverse of tan. So tan is sine over cosine. On that identity sheet, cotan is cosine over sine. So again, we're using the strategy of when in doubt, change everything into sines and cosines. And now from here, it's not very hard. Sine times 1 over sine, those will cancel. So we get 1 over, or we just get 1, I'm sorry. 1 over cos over sine, and then dividing by that fraction is like multiplying by the reciprocal of that. The reciprocal is sine over cosine. So 1 times sine over cosine is sine over cosine, and then what does sine over cosine equal? It equals that right there. So it equals tangent. How do you know when you're done simplifying it? Usually when it looks like that, when you're down to just a single thing. So obviously tan theta is much, much simpler than that mess that we started with. That's usually the signal that you're done. You really can't simplify any more past that. Alright, let's do a couple more here. Like I said, the majority of these is just a question of going through the practice of them. So let's start with 2a. We'll need some space. So a couple ways you can do this. In general, when you see something over a fraction, when you see a fraction like this, it's often easy to split that down the middle. And here's what I mean by splitting it down the middle. 1 plus 3 over 4, that's the same as 1 over 4 plus 3 over 4. So let's split this down the middle. We'll do it over here. So tan squared cosec squared over, and I'm omitting the thetas, but in theory they should be there, but just to save some time. Okay, all I did was split that original fraction down the middle. Okay, when in doubt, change everything to sines and cosines. So I'm in doubt right now. I don't really know what to go from here. Tan, I'm going to change to sine squared over cos squared. Cosec is the reciprocal of sine. It's 1 over sine. And then the bottom sec is 1 over cos squared. Okay, again, we're just following the principle, change everything into sines and cosines. This right here, 1 over sec squared, that's the same as cos squared. Remember, sec and cosine are reciprocals. So now this hopefully is clear why we did this, because now when you do change everything to sines and cosines, things start to appear. So we have a sine squared on top and a sine squared on the bottom. Those will cancel. And then we're left with 1 over cos squared over this thing, over 1 over cos squared. What's 1 over cos squared divided by itself? That whole thing is equal to 1. So this whole thing now becomes this. It becomes, just rewrite this, you can see these start to get pretty involved. So this becomes 1, and we still have that minus cos squared. So 1 minus cos squared. Okay, that's definitely simplified, but it's not quite there. So here's the other thing that I wanted to mention from this sheet, how to prove trig identities. This is strategy 2. Here we go. Try to make well-known identities appear, and the most well-known is sine squared plus cosine squared equals 1. If there's only one that you memorize, that should be it. Try to make those appear, or some variation of them. So a variation of them would be like if I subtracted cos squared from both sides, for example. So let's look at this. This right here, it kind of looks like this identity, except there's some kind of change. So we have 1 minus cos squared. Is there any way that I could make this thing into 1 minus cos squared? I could. There's a 1. If I subtract the cos squared, I would have sine squared equals 1 minus cos squared. So this thing actually equals sine squared. That's how we could simplify it down to just one thing. How did I know to look for that? Well, I recognize that cos squared is part of this most famous identity. So when you see a cos squared and you see a 1, that's what it should make you think of. Alright, let's look at this one right here. So this again looks like a mess. Well, conveniently enough, we just found out what this is in the last problem. Let me go back for a sec. 1 minus cos squared, that equals sine squared. So if you recognize that from the start, we might as well change it right away. If you don't recognize that, you can still get it right, but that will save us some time. So this is the same as sine squared, and because I have a fraction, I'm going to write that as a fraction, so it's self over 1. Okay, sine goes into itself once, and it goes into that. One of those two sines cancel, so we're left with sine theta. So you get sec theta times sine theta. When in doubt, change everything to sines and cosines. So this thing is 1 over cosine. And then it's times sine, so this becomes sine over cosine, and that's another identity that we've seen before. Sine over cosine is equal to tangent of theta. So that is the simplified version. Let's just check this one. We got sine squared. Alright, this last one is definitely harder. Verify each identity. We want to verify that those two sides, remember identity means that the sides are equal. Let me just erase this so we have more space. I want to change the left side into the right side. So easiest way to do this is pick the more complicated side, and that's something that it says on this strategy sheet. Pick the more complicated side. It's easier to take something complicated and make it simple than vice versa. So the left side does look a little bit more, I mean you might say they both look complicated, but the left side does look harder. Okay, and then in general what we want to do when you see something being, so by the way, there's many different ways to solve these problems, so the way that I'm going to show you is not the only way, but in general what you want to do when you see a fraction, it's a good idea to do what we did before, which is split it. So we'll have cosec squared over sine squared minus 1 over sine squared. Okay, and then I'm only going to stay with one side. There is a strategy that says you can try to make them meet in the middle, but I don't know what to do with that. So I'm just going to stick on the left side, and I'm going to try to change it so that it looks like the right side. That's what we're doing when we're proving an identity. We want to make those two sides be equal. Okay, so 1 over sine squared, that's the same as cosec squared. That's on our identity sheet. That's a good sign because I want a cosec squared to be there, so that's at least an indicator that we might be on the right track right there. Okay, and then cosec squared over sine squared. When in doubt, change everything to sines and cosines. So cosec squared is the same as 1 over sine squared, and that's going to be over sine squared. Okay, so I can already tell like this is not going in the right direction, and this sometimes happens. Sometimes in trig identities you reach a dead end. Okay, so if I did this right here, I would get 1 over sine to the 4th minus cosec squared, and then I have no idea how to change this into this thing right here. In fact, even if I did have an idea, I don't want to show you because that's just going to confuse you. So I just want to show you sometimes this happens. You start a problem and it's like a dead end. You don't know where you're going. So you might have to start over. That's completely normal. That's a part of solving trig equations or trig identities. Okay, so what can we do now? Let's go back to our sheet because one of these strategies will always work. So we start with a more complicated side. We did that. Okay, second strategy, try to make well-known identities appear. Sine squared plus cosine squared is the most well-known identity, but it's not the only one. So if we look at the left side, cosec squared, you might remember there is an identity that involves cosec squared. Okay, and I'll point it out to you. It's one of the, anytime you see something squared, you should think of these identities in the middle right here, these Pythagorean identities. Here's an identity right here. You can't see it because there's so much ink on here. This green one right here that I'm highlighting in green, there's an identity with cosec squared. Cotan squared plus 1 equals cosec squared. So let's try to see if we can somehow make use of that to make some progress with this. Oops. So here's the identity that we're talking about. Just move this a little bit. Definitely leave yourself a lot of room when you're doing these problems. So cotan squared plus 1 equals cosec squared. Okay, well we have a cosec squared here, so let's try to make that cosec squared minus 1. Notice that if I subtract 1 from this, I get cosec squared minus 1 is equal to this. Okay, so that means we can now substitute this for cotangent squared of x over sine squared of x. And now from here, this is actually going to be a pretty easy problem. We want to make this thing appear. So now, when in doubt, change everything to sines and cosines. So I can change this. Cotan squared is the reverse of tan squared. So tan, you might remember that tangent is equal to sine over cosine. So that means cotangent is the reverse of that. It's cosine squared over sine squared. And then I have this whole thing over sine squared still. Okay. Well, again, here's the problem. It looks like right now that I'm not going to be able to get if I do this, I'm going to get sine squared times 1 over sine squared, and that's going to be sine to the fourth. But I also noticed this. It's a good idea to look at what you're trying to change something into. So I'm trying to change this into cosec squared on the top. And notice that sine squared is the same as 1 over cosec squared. So it would be a good idea to change that sine squared into what I'm looking for. I'm looking for a cosec squared. So let me change that into 1 over cosec squared. Okay, now there's a saying copy dot flop, which means dividing by a fraction is the same as multiplying by the reciprocal. And I'm almost there. I have a cosec squared on top. I just need a tan squared on the bottom. Okay. Well, what does this equal right here? This is the same, remember, as cotan squared. And you might say, well, why did we change it? That was just to show you when you're in doubt. Sometimes you have to change it. So that's the same as cotan squared times cosec squared. How could I make a tan squared appear on the bottom? Well, remember, cotan squared is the same as 1 over tan squared. Okay, so this is definitely a more involved problem. That's the same as 1 over tan squared. And now notice that if we multiply these, we get cosec squared over tan squared, and that's what we were trying to prove up here. Okay, so definitely a lot of work there, but the more that you practice with these, the better it will be. Okay, let's take a look here. Let's do this one right here. Rewrite that in terms of sine. Okay, well that means let's change these into sines and cosines. So that's the same from our identity sheet. That's the same as cos squared over sine squared. And this is the same as sine squared over cos squared. So when we have fractions, we need to have a common denominator here, and we want to ultimately change these into having nothing but sines. Okay, so let's try that. Okay, so what would be the easiest way to do this? Well, here's our identity. We have sine squared plus cosine squared equals 1. So since we're going to want to change everything into sines, let's solve this for cosine so we can see what we're going to need to plug in. So cosine squared equals 1 minus sine squared. This is what we will eventually have to refer to. We need a common denominator, so the common denominator has to be including both sine squared and cosine squared. So that means this one is missing a cos squared, and this one right here is missing a sine squared. Okay, so now we have this. Now we have big denominator of sine squared times cosine squared, and up here we have cosine squared times cosine squared minus sine squared times sine squared is sine to the fourth. I'm changing that because we want to end up with sines, not with cosines. Okay, what does cosine squared equal? Well, we just saw that it equals this, so let's simplify this a little bit more. So this cosine squared becomes sine squared times 1 minus sine squared, and this right here becomes 1 minus sine squared times 1 minus sine squared. And we still have this minus sine to the fourth right here. Now all we need to do is just FOIL this stuff out, and we'll be good to go. So the bottom FOILs out. If we distribute the sine squared, we would get sine squared minus sine squared times sine squared would be sine to the fourth. And then this thing, when you FOIL it, is going to be 1 minus negative sine squared minus another sine squared would be minus 2 sine squared. And then negative sine squared times negative sine squared would be positive sine to the fourth. But then we have this minus sine to the fourth right there, so those were going to cancel each other out. So our final answer would be 1 minus 2 sine squared theta, and then this bottom part right here would be sine squared theta minus sine to the fourth, and we did what they asked us to do. They asked us to put everything in terms of sines, and we just did. Alright, these are just a couple more kind of along the lines we already did, so I just want to try, let's try to find one here that would be good to do. Some of the tougher ones. Let's do maybe a couple of these. So let's do 22. We haven't done one like that before. 22 and 26. So we see this new thing that we haven't seen before. Cos pi over 2 minus theta. What does that mean? Usually if it's something you haven't seen, it means it's probably on this identity sheet. So let's look at this. So cos pi over 2. Let's see if we have an identity for that. And we do. We have one right here. Cos pi over 2 minus theta, that's equivalent with sine. That basically means that you shifted the function pi over 2 is 90 degrees. So you shift it at 90 degrees, and you might remember from chapter 12 that's going to give you the graph that looks like sine. So let's just replace cos pi over 2 with sine, and then it should be pretty easy from there. So this thing right here, again, that equals sine. So sine theta times cotan theta. When in doubt, change everything into sines and cosines. So cotan is the same as cosine over sine. And now these are going to cancel, and that just leaves us with cosine. Okay. How about this one down here? This is an identity on the sheet. Cos of negative theta is the same as cos theta. And sine of negative theta is negative sine theta. That's on an identity sheet. So this is tangent, except there's a negative right there. So that would be the same as negative tangent. And you start to recognize these identities. Sorry, other way around. Tangent is sine over cosine. Cos over sine is cotangent. So that was my mistake. I was about to say you'll start to recognize these, but unless you're careless like I was, and then you won't recognize them. Let's just do this one. This is an identity on the sheet. This is cosec squared. So it's getting kind of messy here. Let's divide this off. So we have sine times, and half of these problems are about recognizing the identities. That's really the challenge. Okay, how do we simplify this? Well, when in doubt, change everything to sines and cosines. Cosec is the same as 1 over sine, and I'm squaring it because it's cosec squared. Okay, then this sine will cancel, and one of those two sines will cancel, so we're left with 1 over sine, and 1 over sine is the same as cosecant, so that's where that comes from. Alright, last one that I want to show you is, let's see, actually let's do all of these. These are good practice. So this is, again, if you see sine squared and you see a 1, it should make you think of this identity right here. And if we subtract sine squared from both sides, we see that 1 minus sine squared is equal to cos squared. So this is the same thing as cos squared over sine squared. And that's an identity. Cos over sine is equal to cotan. So cos squared over sine squared would be that right there. Okay, this has a common denominator, the sine squared, so we can combine those, and we'll have 1 minus cos squared, and again, this makes us remind of this one. 1 minus cos squared is equal to sine squared, so we would have sine squared over itself, and that is equal to 1. Last one, when you see parentheses next to each other like this, usually that means FOIL them, so 1 times 1 would be 1. 1 times negative sine would be negative sine. This is going to be a difference of squares, by the way. 1 plus sine, 1 minus sine, that's a difference of squares. That's going to be plus sine. And then finally, sine times negative sine is negative sine squared. Minus sine and plus sine cancel, so we get 1 minus sine squared. Again, what does that make us think of? It makes us think of this one up here. And we know that 1 minus sine squared, we did that already. That's equal to cosine squared. So that's section 13.1. It's definitely a little bit tough the first time you do it, but it becomes a lot easier with plenty of practice. So that's the key.